Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 11th grade topic, completing the unit circle. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today or even your own homework, you can always put in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. Today's video will have 4 parts, so leave a like, smash subscribe, and let's get started! Before we jump into completing our first unit circle for today, let's first talk about some expectations, because if this is your very first time looking at a unit circle, when I say we're going to complete it and we're going to see how it's so simple to do so, you may think that I am full of it. If you see something like this does not look simple to complete. It looks like a lot of numbers here, and trying to remember all this, it seems like it's going to be a very tall order. But I'm assuring you that you don't have to memorize the entire unit circle in order to complete the unit circle. This unit circle has so many patterns that we can take advantage of as long as we remember a short, small portion of it. If we remember that small portion of the entire unit circle, we can create the rest of it. That does mean we have to commit some part of this to memory. It's not like you just create it and you just put any numbers in here you want. You do have to commit some small portion of it to memory. However, instead of memorizing everything, you can memorize, like I said, that very small portion and create everything, recreate it all using the patterns that are available to you. Now, I'm not going to go over every pattern that exists here, but I will go over what you need to complete this unit circle. Feel free to check out your own unit circle and see if you can identify even easier patterns for you. Now, there are 2 things that we can observe by looking at this unit circle here. Before we jump off this picture, notice the first thing is this is indeed a unit circle centered at the origin. That means that our circle has a radius of 1, and that's very important for completing this unit circle. The second thing is there's a ton of numbers here. There's so many different types of numbers, and that's because you have essentially 3 different types of unit circles that you can complete. You have a unit circle for degrees, you have a unit circle for radians, and you have a unit circle for values. Now, what do I mean by values? Well, if you were to plug in your radians or degrees into your trig functions, the outcome is what you would call the value. So you can technically complete the unit circle for all 3 of the different versions, and I'll show you how to do each and every one of those right now. But we got to start with 1. So we're going to jump into the radians first, and that's just a personal choice. You can jump into any one you want. However, I'm going to start with radians, and then we're going to move to degrees, and then finish it up with the values. Welcome to our first blank unit circle for today. We're going to be filling this in with a bunch of radians. Now, the pattern for filling in your unit circle when you have radians is going to be based around counting. If you can count, you can fill the rest of this in. And you're going to be counting by 2 numbers. The first number is going to be, actually you can pick which one you want, but it's going to be either pi over 6 or pi over 4. You're going to be counting by one of these 2. And you'll see what I mean by that. So the very first one, you have to remember this. Remember, we're going to start with quadrant 1 up here, and we're going to fill in the rest of the quadrants, but we're going to start with pi over 4 in quadrant 1. Now, I'm going to keep this a little bit lower so it doesn't get confusing, but I want you to remember these are going to be the numbers that you're counting by. So we're going to start with pi over 4. That's the one we're starting with, and that's going to be smack dab in the middle. Now, forgive me, this is not going to be perfect, and you can see you got some lumpy circles here. But don't worry about how perfect it looks, but find the pattern or follow the pattern that I'm going to show you. Pi over 4 is going to split this first quadrant right in half. So this right here is pi over 4. And I said counting, and we're going to count by pi over 4. So what's another pi over 4? We're starting here, and we're going up to pi over 4. So we're going around the unit circle this way. And we're going to go from 1, 2, 3 to 4. And we started here, and we went up to pi over 4. So if we keep going in this fashion, what's pi over 4 add it to pi over 4. We're going to keep counting by pi over 4. Well, you're going to get pi over 2, right? Or you're going to have 2 pi over 4, which can simplify to pi over 2. And that's going to be right here. So this cut in half. So another half puts you right up top. So this is going to be pi over 2 once you simplify it. So you're going to start here, and then you're going to do another half. It's technically 2 pi over 4. So another pi over 4 will be 3 pi over 4, right? So this is going to be 3 pi over 4. And another pi over 4 is going to bring you here, which is going to be, let's say, 4 pi over 4, which is simply what when you reduce it? Pi. It's simply going to be pi. So you see, coming from here all the way to here, you've traveled pi. Pi over 4, 2 pi over 4, which is just pi over 2, 3 pi over 4, pi, or 4 pi over 4. And we're going to keep this going. And we're going to pretty much go another half from here, which was 4 pi over 4, to 5 pi over 4, right? 4 pi over 4, 5 pi over 4. Keep going. This is 6 pi over 4, right? 6 pi over 4, but that can be simplified. What can 6 pi over 4 be simplified to? Well, this is going to be 3 pi over 2 when you simplify it. So 3 pi over 2. But that was 6 pi over 4. So when you go here, it's going to be 7 pi over 4. You're counting. And then up here, you're going to have 8 pi over 4, which can be what when you simplify it? 2 pi. So you've gone from here all the way around back to here, which is 2 pi. So you see, this is a very simple pattern. You're just counting. You start at pi over 4, and you keep traveling pi over 4. And every time you get to something you can simplify, do so. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. If you can count, you can do this. And we're going to do the very same thing for pi over 6. So we've already looked at pi over 4. Now we're going to look at pi over 6. Now pi over 6 is going to be less than pi over 4. So you're going to have this over here. And it's going to be pi over 6. And we're going to do the same exact thing. We're traveling the same exact way. So when you go and you're adding pi over 6 or counting by pi over 6, the next one is going to be 2 pi over 6, right? And that's going to be still in this first quadrant. And that's going to be 2 pi over 6, which can reduce to pi over 3. 2 pi over 6 can reduce to pi over 3. But that still is 2 pi over 6. Now, you count by pi over 6 again. You have another pi over 6, means that you're going to be here at 3 pi over 6. And what's 3 pi over 6? If you look at this, 3 pi over 6 is going to be what when you reduce it? 1/2 pi or pi over 2, which we already have right there. So you see, we went from pi over 6 to pi over 3 to pi over 2 when you simplify. But technically, all you're doing is pi over 6, 2 pi over 6, 3 pi over 6. And we're going to keep this up. It's going to look pretty much the same way for each and every other quadrant. So we move from 3 pi over 6 to 4 pi over 6, which we know to be what? What do you get when you simplify 4 pi over 6? You're going to get 2 pi over 3. But that technically was 4 pi over 6. We just simplified it. And we're going to travel another pi over 6, which gives you 5 pi over 6. 5 pi over 6. Then you get another pi over 6, gives you 6 pi over 6, which can reduce to what? Pi. So because we have the same thing, we know we're on the right track. We're doing what we should be doing. So 6 pi over 6, the next one should be 7 pi over 6. We can't simplify that, so we leave that how it is. The next one should be 8 pi over 6, but that can be simplified. So instead of having 8 pi over 6, 8 pi over 6, what can that simplify to? 4 pi over 3. 4 pi over 3. Perfect. All right. So we have 8 pi over 6 that we simplified to 4 pi over 3. But remember, it was still 8 pi over 6. That means this is going to be 9 pi over 6, which can reduce to what? 3 pi over 2. We already have that. We're still on the right track. We're still on the right track. Now, this may seem a bit confusing with the simplifying during the creation. So if that's confusing to you, don't do it. Create it, then simplify it. So this was what again? 9 pi over 6. So this is going to be 10 pi over 6, which you can simplify 10 pi over 6 to what? 5 pi over 3. 5 pi over 3. And then last but not least, well, I guess technically not last, but if that was 10 pi over 6, this is going to be 11 pi over 6. Just like that. 11 pi over 6. Finally, this is truly our last one. We're going to add another pi over 6, which brings us to 12 pi over 6. And you can simplify 12 pi over 6 to what? 2 pi. So you don't necessarily need to write that because we already have a 2 pi there. We already have that right there. So you see, we were on track the entire time. You're counting by just these two numbers. You do them one at a time so you don't get confused, but you're counting by just those two numbers. And quadrant 1 is repeated in quadrant 2, quadrant 3, and quadrant 4. Using the same pattern. If you can count, you can do this pattern. So now we're going to move on to our next unit circle, which is going to be our degree circle. This was our radians, and we're going to move on to our degree one. Now, radians and degrees are tied to one another. You can go back and forth between them, and we're going to exploit that. And instead of having to remember a whole nother pattern, let's start evaluating things. To complete the degree unit circle, there's a very easy pattern that we can take advantage of. And I can actually make mention of that towards the end of this unit circle, but I want to show you another way of filling this out using your radians. If you already have the radians on it like this, notice I didn't erase anything, you can actually use this to figure out your degrees. And that's because pi is going to be 180 degrees. If we know that simple fact, pi in radians equals 180 degrees, we can convert all of these radians to degrees, and therefore we can easily fill in our degree unit circle. So you have to remember that pi is going to be 180 degrees. So if that's the case, substitute 180 in for every place you see pi, and you have your degree unit circle. So this is going to be 180 divided by 6. So what's 180 divided by 6? Well, that's going to be 30. So you're going to have 30 degrees here. I'm going to have to squeeze this in because I don't have a ton of space. But I'll say it so you can kind of follow along in your own work. But this is going to be 30 degrees. Now you have 180 divided by 4. That's going to be 45 degrees. 180 divided by 3, 60 degrees. 180 divided by 2. This is going to be 90 degrees. 180 is going to be multiplied by 2, but then divided by 3. So what's 2 times 180 divided by 3? Well, this is going to be 120 degrees. How about 3 times 180 divided by 4? You can put all this into your calculator if you need to, or you can just use some scratch work. 3 times 180 divided by 4, 135. 5 times 180 divided by 6, 150. And make sure you put your degree signs here so you know that these are truly degrees. We already said that pi is 180, so you could just smack that right there. 7 times 180 divided by 6. That's going to be 210 degrees. 5 times 180 divided by 4. That's going to be 225 degrees. 4 times 180 divided by 3. This is going to be 240 degrees. 3 times 180 divided by 2. 270 degrees. 5 times 180 divided by 3. This was going to be 300 degrees. 7 times 180 divided by 4. This is going to be 315 degrees. 315. It's kind of hard to read these now. Let me try to make them a little more straight. I said this was 300 degrees, and this was 315 degrees. 11 times 180 divided by 6. This is going to be 330 degrees. Now, finally, 2 times 180. 360 degrees. So if you already have your radians, you can use your conversion method. Knowing that pi is 180 degrees, simply plug in 180 into each and every one of these radians to find the degree equivalent. But let's say you don't have your radians. Well, there's a simple pattern here that you can take advantage of. Like I said, this is very, very simple. If you're starting here, we always start here, and we're always going to travel this way, all right? Counterclockwise, traveling this way. It's going to be 30 up, 15, 15, 30. Remember, 30 up, 15, 15, 30. And you're going to keep doing that same exact pattern. So it's 30, 15, 15, 30. If you can remember this pattern here and count by that, you can easily fill in the rest of this unit circle. 30 up, 15, 15, 30. 30 up, 15, 15, 30. And notice, when you add 30 to 90, you get 120. Add 15, 135. Add another 15, 150. And then your final 30 at 180. Then from 180, add 30, 210, add 15, 225, add another 15, 240, add 30, 270. Then another 30. So every time you get into a new quadrant, you start this pattern over. You get 300, 15, 315, 15, 330, finally another 30 at 360. So the pattern for degrees, if you can remember it, 30, 15, 15, 30. Let's jump into our final unit circle for today, our value circle. So for our last unit circle for today, our value circle, we're going to be actually using these intersection points with the axis. So this right here didn't really come into play for our 2 other unit circles, but they do play a role for the value one. And unlike the other 2 unit circles, this one does have a little bit of counting that you have to do, but is not going to be on the same level. The pattern for this really uses what we know about our quadrants, and there's a lot of repetition. So it's not necessarily the counting that we have to make sure we pay attention to. That's just to kind of get us started, but it's going to be repeating using what we know about quadrants. So what do we know about quadrants? We know that in quadrant 1, both x and y, any point here is going to be positive. X is going to be positive, y is going to be positive. How about quadrant 2? What do we know about x and y? Well, any point here, your x is going to be negative and your y is going to be positive. We know that to be true. Quadrant 3, any point in here, your x and your y are both negative. And quadrant 4, you have positive x, but you have a negative y. So we're going to be using what we know about our quadrants to do a bunch of repetition. But first, let's get started with a little bit of counting. So we're going to count, and we're going to go this way. So unlike before, we're going to go clockwise. And we know that we have our 3 lines intersecting our circle in this fashion. Now, what are we counting by? So we're going to be counting by 1/2. However, it's not going to be a pure 1/2. I assure you it's going to make sense. We need this to develop our starting point. However, there's a pattern that we can use that looks like this, but we're going to do something special. It's not going to be a pure 1/2, but stay with me. So we're going to start with 1/2, and we're going to start up here going clockwise. So from 0, the very first one, we're going to start our x point is going to be a 1/2. All right, we're going to fill this in a little bit later, our y point, but we're going to start with our x point going down. You see we're increasing from 0 to 1. So we're going to keep going by 1/2, and this next one, although it makes sense to kind of be here, because when you add 1/2 to 1/2, you get 1, but like I said, stay with me. This is going to be 2 over 2, right? 2 over 2. And the next one is going to be 3 over 2, right? You're just adding 1/2. Now, this doesn't make any sense just looking at it. From 0 to 1, you shouldn't have 3 halves. However, like I said, we're going to do something special to this. Every numerator is going to get a square root. Now, it makes a little bit more sense because this is no longer bigger than 1. Every numerator gets a square root. And we're going to do the same thing in reverse. In reverse, starting at 0 here for the y point. So we're going to start at 1/2. Then we're going to go to 2 over 2. Then we're going to go to 3 over 2. Except, just like before, we need to put everything in a square root, or every numerator in a square root. Now, I said before, simplify where you can. You can simplify this square root of 1. What is square root of 1 going to be? That's just going to be 1. So technically, that's 1/2. And you have another square root of 1 right here. So that's also 1/2. However, you can't really do anything with the other ones. So this is going to be what you need to remember to do. Once you do a little bit of counting in this fashion, it's just repetition. These are the 3 numbers that we're going to repeat throughout the entire unit circle. 1/2, square root of 2 over 2, and square root of 3 over 2. Everything is going to have this, except it's going to be positive or negative. And that's going to depend on the characteristic of that quadrant. So if you want, you can make your 3 lines, 1, 2, 3 for each of these. These are not going to be perfect, but you get the point. And now we start filling in. So this is our very first one that we're running into. We're traveling still this way, counterclockwise, to fill in our unit circle. And we already know what our points are going to be. We just got to figure out what their signs are going to be. So in quadrant 2, we know once again, our x's are going to be negative while our y's are going to be positive. And this is just going to be mirroring each other. Make sure that this axis here, you mirror the point about the axis. You mirror it. It should be the same exact one. You shouldn't be using this point up here. Mirror around the axis. You're going to do the same mirror around this axis, the same mirror around this axis, the same mirror around this axis. Whatever the point is that's most closest to that axis is going to be the first point here. So this is going to be a 1/2 and a square root of 3 over 2. Except we know that our x's have to be negative. So this is going to be a negative 1/2. Now we're going to go down. We'll repeat this. We're going to just replicate. So this is going to be square root of 2 over 2, square root of 2 over 2, and this is a negative. Over here, square root of 3 over 2, 1/2, negative. That's all you have to do for this. Now we move to quadrant 3. We're going to mirror over this axis. So the very first one is going to be our square root of 3 over 2, 1/2. So since we're in quadrant 3, both of these are going to be negative. And here is going to be square root of 2 over 2, square root of 2 over 2, and both of them are going to be negative. And this one, I'm going to shorten this a little bit, squeeze this in a bit more. And this is going to, I'll just put it right here. It's going to be 0, negative 1. This is going to be, what was it up here? It was 1/2 square root of 3 over 2, except both of these are going to be negative now. Now we're going to mirror over this axis here. So this is going to be a 1/2 square root of 3 over 2, except because we're in the 4th quadrant, only the y is negative this time. Then we have our square root of 2 over 2 and our square root of 2 over 2 where our y is negative, followed by our square root of 3 over 2 and our 1/2 over 2 where our y is negative. This is a negative 1. Negative 1. It doesn't really look like negative 1 now. My smudging. Negative 1. And notice that this is reflected over here. This x-axis here, we're reflecting this. It's the same exact point. We just negate it as necessary. So this is our unit circle that we filled out using our values. I hope you have followed on to these examples, and I hope you now know how you can complete all 3 of your unit circles. However, if you have any questions about what we saw today or even your own homework, you can always put it in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Senpai.